Surface area of pyramids. We're just looking at square-based pyramids at this point. So we have a square on the bottom, triangle edges meeting at a point. A pyramid is obviously not a prism. It does not have an identical cross-section all the way through, so we cannot treat a pyramid in the same way that we would a prism. We need to be able to draw the net of a pyramid, and it's a really good idea actually to think of it in terms of a net. So your idea is, imagine looking down at that pyramid. You would see a square, so you start by drawing a square. If you're drawing a net, please make sure that you use a ruler, and we will label our sides with the lengths. We don't have to draw it to scale. So that is our square looking down, and our side lengths would all be 2 meters. Then your idea would be, imagine that you're looking down at that pyramid and folding out all those triangles. And how I find it easier to envisage is, obviously the point of your triangle will be in line with the middle of the base. So I tend to just put the point of the triangle in the right spot and draw my straight lines with a ruler to make my triangles. Now for finding the surface area of this shape, oops, missed one side, we will of course need to find the area of the triangle, multiply it by 4, because there's 4 triangles, and add the area of the square base. Remember, you will need to give the height of the triangles. Also be aware that often a pyramid's height is given, and it is the distance from the center of the base perpendicularly, that is at right angles to the base, to the top point. That is the height of the pyramid but this value here, 3 meters, is the height of the triangular side or face. So we need the height of the pyramid later on when we're finding the volume. We need the height of the triangular face to find the area of that triangle. In some situations in an extension problem, you might not be given both of those values, and you might need to use Pythagoras' theorem to work one out, because you can see if I add an extra line in there, I can see that would be 1 meter because it's halfway across that 2 meter distance, with 3 meters there as the hypotenuse. I could then find the height of the pyramid. If I'd been given the height of the pyramid but not that distance on the triangular face, I would have to use Pythagoras to find that length on that triangular face. In this example, I've given you the lengths that you needed. So finding the total surface area, I tend to prefer writing a formula for the whole surface area, because that would be the area of the square, which would be side squared or length squared if you think you're likely to get s mixed up with 5, plus 4 times the area of a triangle, which is half times base times height. Sorry, I'm sometimes putting the multiplication signs in and sometimes not. That's a bit unhelpful of me. So the side of the square, we have 2 squared plus 4 times a half. We can simplify that down to 2. Base of the triangle is 2 meters, height of the triangle is 3 meters, and this is working out nice and easy because I have 4 plus 6, which is 10. We're in meters, and we're in surface area, so I'm in meters squared. So it's quite simple as long as you think of the net of the pyramid and you're finding the area of the square base plus the area of the 4 triangles. It's worth remembering that with a composite shape, sometimes you've got a square pyramid on top of, say, a square prism. Be aware that sometimes you won't need that square base. It won't be part of the outside of the shape. So this part is the square base. This part is the area of the triangles. And if you were solving a more complicated problem, you might need to ignore that square base.